Lesson 85, Finding Polynomial Roots, Part 2. Okay, so the sum of two cubes equals the first plus the second, the first squared, minus the first and second multiplied, plus the second squared. And then the difference of two cubes is the same, only it's a minus sign in the beginning, and then a plus sign in that second factor of the second one. Okay, so let's say you have a difference of two cubes. So we're just going to do some examples so you can see some of how you can do these also. So when we factor, this is just x cubed minus 5 cubed. So we can plug into this formula up here where x is x and 5 is a. So we just do x minus 5 times x squared plus 5 times x plus 5 squared, which is 25. Set it equal to 0, so we want to find the roots. That means where it crosses the x-axis. And we have x minus 5 equals 0, so x equals 5. Then the other one, when we do this graph, we can just graph it in the graphing calculator and see if it crosses the x-axis. You can actually picture this graph, maybe, in your head, and it will never, like y will never be 0 here. Maybe you can't picture that. We can graph it in our graphing calculator. And just to double check.
Wait, what if it's like...
So we have x squared plus 5x, that's not x, that's x, plus 25. And then just do like a zoom fit or something. Okay, so then, let's see, we'll just trace. Zoom back out. So I want to know if y ever gets to 0. And you can see right there it doesn't. So it doesn't ever touch, y won't ever equal 0 on that one. So my solution is just x equals 5. Yeah, here's a bunch more examples. So if we have f of x equals x to the 6 minus 729. That's the difference of two cubes, where you have the first one is x squared cubed minus, and 729, the cubed root is just 9.
Oh, this is going to be nasty.
So we have, this is going to be like beautiful.
This is going to be very green, yeah.
So we have x minus a, and then we square the x squared to get x to the 4th. Then we add the 9 and the, we add the product of the two, and then plus 9 squared, which is 81. Then check it. Here's the difference, two squares. So you get to factor again, x minus 3, x plus 3. Then we have x to the 4th plus 9, x squared plus 81. And again, you will plug this into your calculator. And see if there are any zeros. And on this one there are not. So x will be 3 and negative 3. Those will be the two zeros of this particular function. And the last example on this one, x to the 9th plus 64. So we want to find our x and our a for the sum of two cubes. So x cubed means x to the 9th plus, and then the cubed root of 64 is 4. So plus 4 cubed. So it's the sum of two cubes. So we have x cubed plus 4 Then we have to square x cubed, which is x to the 6th minus 4x cubed plus, and then we do 4 squared, which is 16. So to find the 0, we can do x cubed plus 4 equals 0. We, oh wow. No, I would do this as the sum of two cubes. Ugh. So we have x cubed plus the cubed root of 4 cubed.
It's like cube root of 4.
Yeah, so it doesn't have an exact one. So this is x plus the cubed root of 4 times x squared plus x times the cubed root of 4 plus, now we have to square that. So it's the, wait, I'm squaring the cubed root of
Cube root of 16.
4. So it's the cubed root of 16, which is 2
X, yeah, which is 2 to the 4.
cubed root of 2.
Cube root of 2 to the 4. Which is
No, it's just 2. Why'd I put parentheses right there? Does anybody know? I don't want parentheses right there. Right. I have letters somewhere.
cube root of 2.
It's 2 cubed roots of 2. So the cubed root of 16 is 2 cubed roots of 2. So that's the first one, and we still have it times this one. So we need to plug this into our calculator to see that is there any zeros?
No.
No. And then we need to plug this one into the calculator to see if there's any zeros. So while you're doing that, we're going to solve this.
It's just negative.
So x equals negative cubed root of 4. Unless this has zeros, which I don't think it does. I think I plugged it in earlier today.
I have a question.
Okay, so those are examples on this. Could you just do x cubed plus 4 equals 0, subtract 4, take the cubed root. Yeah, you could totally get it by doing this. I don't know why we had to do this.
That's what I was wondering.
Oh, I know why. Because you have to see if there's a 0 in here. You have to see if there's another 0 that we're missing out on. Okay,
Couldn't you just grabbed it?
the whole thing.
Just the x cubed plus 4? Because it would have just moved over 4.
Yeah.
It would have just moved over to the right over 4. So it's
No,
still
not
over
if you add 4, it moves up 4.
up 4.
Yeah.
Wait, then it
So
should
it'll
have, then it should.
just have 1 0. Okay. All right, there is a theorem we have to go over. It's called the rational root theorem. It's kind of ugly, but I'll try to go not too fast. When you have a polynomial, and so we're going to do a sub n x to the nth power plus a sub n minus 1 to the x to the n minus 1 plus, and we're going to continue on until we have a constant a sub 0. The rational root theorem says that if you find all the factors of a sub n and a sub 0, then you can make a fraction out of each one of those factors to find roots. So what we do is we let q be a factor of a sub n, and let p be a factor of a sub naught. So you can make a fraction, well, you can list all possible q divided by p, and the factors will be within that list. So you test x minus q, wait, was it supposed to be p over q? Oh shoot, It is supposed to be P over Q. That's all. You just put the 1 for A sub naught over the 1. Okay. To see if it's a factor. So there's a lot of guessing and checking, and it can be kind of tedious. So I'm going to give you just one example.
I don't get it.
Well, that's because there's a lot of P's and Q's and A's here.
It ends.
And you got to mind your P's and Q's.
And
And that's really hard sometimes. It just means you list all the factors of the coefficient and the constant.
Okay.
List them all.
Okay.
All the factors you get for this one, A sub n, call them Q.
Oh.
And all the factors of A sub naught, just call them P. Now take one factor from Q and one from P and make a fraction. That could be a factor.
A is the coefficient of every single number?
No, just A sub n is just the coefficient of the one with the
You're doing
highest
that?
degree.
Wait, the highest degree. So that's your first one and your last one. That
Yeah.
is the stupidest way of saying something so simple.
I know, but it's only a mathematical way of saying it so that you can use it for every polynomial. Okay, here's an example. X to the cubed plus 4x squared plus x minus 6 equals 0. So remember that Q is the coefficient of the highest degree. So Q is all the factors of 1. So it's just plus and minus 1. And then P is going to be all the factors of negative 6. So you have plus and minus 1, plus and minus 6, plus and minus 3, and plus or minus 2. So we want to make fractions P divided by Q and then test them. Yeah, we've done
You get
something very
1,
similar.
6,
Yeah, how we find the multiplicity and stuff.
So let's start with
That's stupid, I hate
like
it.
2 and negative 2. We'll test x minus 2, x plus 2. We'll just test those. So if x minus 2 is a factor, then 2, with the synthetic division, you can put a 2 here and do 1, 4, 1, negative 6. See if we get a 0 on the end. So we'll bring that down to,
Wait, you forgot your 0.
I did.
No, you didn't, sorry.
Then
I
we
forgot
add,
the
wait, do we add? I feel like we add. Times, add, 13 times 2, 26, uh-oh, that's 20, so no, 2 is not a factor. So we'll try the negative 2. We have 1, 4, 1, negative 6, bring down the 1, negative 2, add, you get 2, negative 4, add, negative 3. Oh, this is looking good. Okay, so that's nice. X plus 2 is a factor, and we're left with x squared plus 2x minus 3 equals 0.
That's being
Then I think we can factor this.
How'd you get the
positive
Plus
3,
That's-
negative 1. Oh.
So x plus 3, x minus 1 equals 0. So the x's are negative 2, negative 3, excuse me, and positive 1. That's the end of the lesson.